Hello, today's video is about adding and subtracting fractions without the same denominators. So I want to start with a review about mixed numbers and improper fractions because you might see that along the way. So remember, a mixed number is basically a whole number and a part that's a fraction. That's why it's called mixed. And really the way I say this is 1 and 3/4. So you can think of the and as a plus sign between the whole number and the fraction. So this is 1 whole square and 3/4 of a square. So that's why it's 1 and 3/4. And then an improper fraction, right? We call it improper. It's not really improper, but the numerator is bigger than the denominator. And so when you change a mixed number to an improper, you have to actually look at the denominator and count how many size pieces there are. So I'm going to cut this fraction into fourths because this one's already into fourths. So you look at the part and then you make a whole have the same size. And then I could just start counting, right? 1, 2, 3, 4, 5, 6, 7. There are 7 fourths. And the math that we do is we take the denominator and the whole number and we multiply those and then we add in the extra 3 there. So it's 4 times 1 is 4 plus 3 is 7. So this is equal to 7 fourths. Now, if I have a fraction that's improper, I'm basically dividing. Remember how I always told you that the fraction bar means to divide? So I figure out how many times 4 goes into 10, and it goes 2 times. 4 times 2 is 8. When I subtract, I have 2 left over. Those 2 are the extra pieces that are in fourths. So I can say that 10 fourths is the same as 2 and 2/4. But then you should recognize that 2/4 is a fraction that can be simplified by dividing by a giant 1. And 2 divided by 2 is 1, and 4 divided by 2 is 2. So the whole thing simplifies to 2 and 1/2. Okay, so now let's look at this warm-up. So I'm going to have you practice that what we just did, turning mixed numbers into improper and then improper into mixed. Go ahead and pause the video and see how you do. And I'm just going to show you the pictures that go with it. So there's 3 whole pizzas, and then I have 3/4 of a pizza. So what I want to do is when I multiply 3 times 4, what I'm doing is I'm taking the 3 whole pizzas and I'm cutting them all into fourths. So 3 times 4 is 12, plus the extra 3 is 15. So this is equal to 15 fourths. And if I highlighted the 3/4 that were here, you could see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 fourths. All right, so you try B, pause it, and try it, and I'll show you the answer. So here's the picture. It is 4 whole pizzas and then 4/5. So 4/5 would be this part of it. And then this would be 4 times 5 is 20, plus 4 is 24. So we get 24/5. And the picture that matches it, it's not easy to do fifths in circles. 1, 2, 3, 4, 5. So you basically make 5 little sections here. 1, 2, 3, 4, 5. Not doing a very good job, but I'm just showing you basically the reason why I don't like circles for fifths is it's hard to make fifths. Okay, now I have improper to mixed. So I'm trying to figure out how many times 7 goes into 3. And so that's not helping. I'm going to go like this. I'm going to go 3 goes into 7 2 times. 3 times 2 is 6, and I have 1 left over. So what I'm looking at for 7/3, I'm going to go ahead and draw a picture of what 7/3 would look like. So I've got 3 candy bars, right? And when I cut them all into thirds, I count 1, 2, 3, 4, 5, 6, 7 thirds, right? These ones are already gone. So I have 2 whole candy bars plus 1/3 left over. 2, I take this one that's left over and it's cut into thirds. So the answer is 2 and 1/3. All right, so try D, pause the video, and then I'll show you the answer. I have 11/4. So I'm going to make 4/4. 1, 2, 3, 4. And then see that 11 fourths would be 9, 10, 11 fourths. So I can see that I have 1, 2 whole candy bars plus 3 fourths. And here's the math that we do. 4 goes into 11 2 times. 4 times 2 is 8. When I subtract, I have 3 left over, and they're cut into fourths, so it's 2 3 fourths. Okay, now I want to basically show you, the question is, for the essential question, what must be true about the size of pieces when adding and subtracting fractions? And the answer is that the pieces have to be the same size, right? So the idea is you figured out, right? We've been practicing finding the least common multiple. Well, the least common denominator, that is the least common multiple of 2 denominators. So we want to use that skill that you learned how to do, where you find the least common multiple and you look at the denominators, and when you find the least common denominator, you are going to change the fractions so that they're the same size. So here's an example of using the least common denominator to rewrite fractions with the same denominator. So I'm going to put the 6 and the 8 in the ladder and use that method to find the least common denominator, right? Least common multiple is the same thing as the least common denominator. So when I divide by 2, I get 3 and 4. They have no more common factors, so all of these factors together are the least common multiple and least common denominator. So 2 times 3 times 4. So 6 times 4. The least common denominator is 24. So here's what I do to rewrite the fractions. I put 1 over 6, and I know I want my denominator to be at 24. So I think about what do I need to multiply 6 by to get 24, and it's 4. So I multiply the top and the bottom by 4. It's like multiplying by a giant 1. So if I multiply 1 times 4, I get 4, and 6 times 4 is 24. And I do the same thing with the 3/8, except that I have 8 as the denominator. So instead of multiplying by 4 over 4, I'm going to figure out what times 8 times what gives me 24. And I know it's multiplying by 3. So I multiply this fraction by 3 over 3, which is the same thing as multiplying by 1. Multiply across the numerators. 3 times 3 is 9. 8 times 3 is 24. That's how you rewrite fractions with the same denominator. I'll show you another example of 9 and 12. If I want to, remember you can make your list of multiples. I can list 9, 18, 27, 36. Now I'm going to start and then let's do 45. Remember I usually said make about 5 in your first list. Now I'll list the multiples of 12. 12, 24, 36. Ooh, I can stop right there because I see 36 is the smallest common multiple, right, in both lists. So now when I rewrite my fraction, what I'm going to do is I'm going to multiply by a number that will give me 36 in the denominator. 12 times 3 is 36, so I know I need to multiply by 3 over 3, right? Every time I multiply by a giant 1, the value does not change. 5 times 3 is 15. I'm creating an equivalent fraction, but just in smaller pieces if you think about a pizza. So now I've got 2 9ths times some number, and I want this also to be in 36. So now I know I multiply 9 times 4, so I write a fraction 4 over 4. There's my giant 1. 2 times 4 is 8. So if you have 5/12 of a pizza, it's the same thing as 15/36. And if you have 2 9ths, it's the same thing as 8/36. Okay, these two I want you to try on your own and then unpause the video. So 7 and 10 have no common factors, so I know I find the least common denominator by just multiplying them together and get 70. So my least common denominator is 70. 4 over 7 times some fraction gives me a denominator of 70. I know 7 times 10, so I multiply by 10 over 10, and I get 40/70 is equivalent to 4/7. And now I'll do 3/10, and I want my denominator to be 70, so I'm going to multiply by 7 over 7, draw the giant 1. 7 times 3 is 21, and 10 times 7 is 70. All right, this one has 3, and if you remember, this one was really tricky if I use the factor ladder with 3 different numbers, right? I'm always using the denominator because I need to change the size of the pieces. I'm going to divide by 2. I get 2, 4, and 5. So the thing with the least common multiple is as long as a factor can go into 2 of the numbers, 2 and 4 are both divisible by 2. So I can put a 2 here. 2 divided by 2 is 1. 4 divided by 2 is 2. And I'm not going to divide 5 by 2, so I just carry that down. And then these are all the numbers that the common multiples, well, only 2 was the common multiple. 2 only goes into 2 and 4, so it's part of the uncommon multiples. And I multiply those all together. 2 times 2 is 4 times 1. So far I've got 2 times 2. Let me put that 4 over there. 2 times 2 is 4 times 1 times 2, which is 2. And then the last thing I have is a times 5, so I'm not going to forget that. 4 times 2 is 8 times 5 equals 40. So I'm rewriting all of these fractions to have 40 as the denominator. So I'm going to multiply by a fraction to give me 40 on the denominator. 4 times 10 is 40, so I multiply by 10 over 10, and I get 30/40. 5/8 times a fraction, and I want the denominator to be 40, and 8 times 5 is 40, so I multiply by 5 over 5. 5 times 5 is 25, and the last one is 1/10 times some number, and I want the denominator to be 40, and I know if I multiply by 4 over 4, 1 times 4, there's the 3 equivalent fractions. Okay, now I'm going to show you a couple of examples, and then will be like one example and one OYO. So let's look at a question that says, Mr. Norris ate 5/8 of a large pizza. Miss Cliffner ate 1/6 of a large pizza, right? A different pizza. How much of a whole pizza did they eat altogether? So I can look at this circle, right? I want to show you what 5/8 looks like, right? The top half is 4/8 plus 1 more is 5/8. And then this pizza is cut into 6. So if I highlight one of these, it's 1/6. But they're not the same size, right? This is 5 pieces. This is 1 piece. But these are bigger pieces. So what I'm trying to do is I'm trying to look at the denominators, the 6 and 8, and find a common multiple. If I make a list of factors, in multiples, I get 6, 12, 18, 24, 30. When I make a list of the 8s, I get 8, 16, 24. Oh, there we go. So I know the common denominator is going to be 24. But here's kind of what it looks like. What I'm trying to do is I'm going to change the 8 size pieces. There's 5 of them, and they're cut into 8s. But what if I cut them into 24ths, right? When I put this right on top, then I can see that there's way more pieces, but they're smaller. So the idea of what I'm doing is I'm taking the 8s and I'm multiplying each of those single, oops, I didn't mean to draw that. Each of these little things, I can see that 1, 2, 3 of these is equal to 1 of those. And so that's what I want to try to do. So I'm trying to figure that out. And how I figure that out is by taking the 5/8 and realizing that I need to make it a denominator of 24 because that was the common denominator. So when I multiply 8 times 3, I get 24. And when I multiply 5 times 3, I get 15. So what I'm doing is I'm taking each of these pieces and I'm actually cutting them into thirds. So every time I count one of these pieces, it's 3, 6, 9, 12, 15. That's how I get 15 24ths. Now I'm going to do the same thing with the other pizza. This is cut into 6. And if I move this over, hopefully you can see that it's actually 4 pieces. 4 of the 24ths is equal to a 6. And how we do that with the math is we figure out we're going to multiply by a fraction, and we want 24 to be the size of the piece. 6 times 4 is 24. So if I don't want to change the fraction, I'm always multiplying by this giant 1. 1 times 4, so 4 24ths of a pizza is the same as 1/6. Now what I can do is I can take the 15 24ths and the 4 24ths and I can add those together. And I like to add them together the way I add whole numbers, right? I make a column and then I add. Now, if the denominator is the same size, that's the size of the piece that I'm counting. Now all I do is I add the numerators, the 15 plus the 4. So I get 19 24ths of a pizza. Right, that's how much we ate together. Okay, next. So this is the OYO that I want you to try. And I'm going to show you that if I highlight, so this is 2 1/6, right? If I highlight the 1/6, you can see that this is the size piece that I am replacing it with. And then this one is 3 4/9. So I'm going to highlight 1, 2, 3, 4, and I'm going to drag this piece on top so that you can see that once I cut it into smaller pieces, right, there's many more. The numerator is bigger because I cut them into smaller pieces. Okay, so what I recommend you do is pause the video, try it on your own, and pause the video. And then check your answers. So I've got 2 1/6 plus 3 4/9. So of course the first thing I need to do is find the common denominator. If I want to, I can list 6, 12, 18, 24, 30, 36, and the multiples of 9 are 9, 18, 27, and 36. So I know the common denominator is 36. So what I'm going to do is I'm going to take the 1/6 and multiply it by, I want 36 to be my denominator, so I have to multiply, oops. I thought that seemed too big. I hope you noticed that I don't want to use 36 because that is a bigger denominator than the other smaller denominator that I see. Hopefully you were thinking this. It is 18. Okay, so I'm going to change the 1/6 to a denominator that has 18. So I need to multiply 6 times 3, which means I need to multiply the top number by 3. 1 times 3 is 3. So this 1/6 is now 3/18. So I'm going to cross that off. And then the 4/9, I'm going to take that and I'm going to multiply by a number that gives me 18 in the denominator, which is 2. I have to multiply 2 by 2 over 2 because that's a giant one. And I get 8/18. So this number becomes 8/18. Now when I add the whole numbers together and then I add the fractions together. 3 plus 8 is 11 and the size is 18. So I get 5 11/18 yards of ribbon. All right, next one. Now we have kind of the same thing, but it's a subtraction problem, right? So we're looking at 4 3/4 cups of flour. And then Mr. Norris kindly gives me 2 3/10 cups of his flour. Oops, I forgot to add cups. How much flour is left over? So here's the 4 wholes, plus I'm going to show the 3/4, right? So I have 1, 2, 3/4. That circle was cut into fourths. And then I'm already showing you the size piece that we need, right? So I'm going to take this and put it on top. Oh, yeah, definitely smaller pieces, right? I'm always taking a larger fraction and cutting into smaller pieces. And then what he's going to give away is 2 3/10, right? So the idea is that I want to take one of these away, right? I'm going to take another one of these away. So I can already see that it makes sense that you can subtract the whole numbers, and then I need to think about how I subtract the fractions. And so here is the smaller circle, and I could use a different color to represent how many I'm going to take away, and I'll color this in when we're done. I'm going to go ahead and erase that. Okay, so I'm going to set up the problem first how I like to do my math, just the way I subtract with whole numbers. So I've got 4 3/4, and I'm writing 2 3/10 underneath it, right? I'm going to subtract the whole numbers and subtract the fractions. And I need to find the least common denominator with 4 and 10. So if you want to make a list of multiples, hopefully you'll see that it's 4, 8, 12, 16, 20. And then if I have 10, I go 10 and 20. And 20 is the least common denominator, the least common multiple. So I'm going to multiply the 3/4 times 5 over 5 because I want my denominator to be 20. And the numerator is 3 times 5 is 15. So I'm going to replace this with a 15 20ths. And then I have 3 tenths, and I'm going to multiply by 2 over 2. There's my giant 1, and I get 6 20ths. So I cross that fraction off, and I replace it with, 6 20ths. Now I have my whole numbers. 4 minus 2 is 2, and my fraction pieces, 15 minus 6 is 9. I have 9 20ths. So what I wanted to show you is I could count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then what I wanted to do is I wanted to move this so that you can see that when I went, it doesn't really match up entirely, but when I counted from 1 to 15 in the 20ths, you can see that it matches the 1 to 15 is the same thing as 3/4 of a pizza, right? And there's the 1/4 that's left over. I didn't line that up very well. Okay, and then when I take away 6 of the pieces, I'll only have 9 left, right? So I can count backwards and just take away 1. Oops, I wanted to use a different color. 1, 2, 3, 4, 5, 6. Now I have 9 of the pieces left, and they are in 20ths. Okay, last thing is an try this problem and then unpause the video and check your work. 3 and 9 11ths minus 2 and 2/3. 11 and 3 don't have any common, there's no common factors that I could divide out. So if they have no common factors and they're both in fact prime, 3 and 11, you just multiply them together, right? So 3 times 11, 3 times 11 is 33. That's my least common denominator. Okay, so I'm going to take the 9 11ths and I'm going to multiply it by 3 over 3. And I get 27 33rds. I'm going to take the 2/3 and multiply that fraction times 11 over 11. There's my giant 1. I get 22 33rds. So I replace this fraction with 27 33rds. And I replace this fraction with 22 33rds. 3 minus 2 is 1, and 27 minus 2 is 5. So I get 5 33rds pounds. Okay, good luck on the homework.